In this video, we're going to start with some simple single event probabilities and build up an understanding of that and of expectation. So let's just introduce probability. Well, when you roll a dice, which numbers are you most likely to get? And of course, in this particular case, you can get a 1, 2, 3, 4, 5, or 6. And of course, the answer for part A is they are all equally likely to happen, aren't they? Of course. Okay. Right. So then, if we can use that idea, well, if we roll a dice 600 times, how many sixes would you expect to get? Well, we have 6 different possible outcomes, so they all have an equally likely chance of happening. Well, that means there's like a 1 out of 6 chance of getting each one. So we need to think about a 6th of 600, or 600 divided by 6, because there's 6 equally likely possibilities. Well, that is, of course, 100, and that's going to be our answer to part B. Another way you could think about this is doing 600 multiplied by that probability. It's the same thing, right? Okay, and that might be more useful when we have more complex scenarios later. Would you expect to get the same number of ones? Well, of course, yes, you would, because a 6 is equally likely to happen as a 1. Okay, so if we toss a coin 500 times, how many times do you expect it to land on its side? Well, 0 times, because it's just not going to happen, is it, right? Heads up, well, there is a 50-50 chance of getting a head or a tail. Okay, in probability terms, we like to use fractions or decimals, so we could say there's a half probability of getting a head. It happens half the time, and tails half the time too. So that's the probability. So if I want to throw it 500 times, I need to find a half of 500. Well, I am doing 500 divided by 2, of course, which is 250. So I'd expect heads to be 250 times. And of course, it's the same thing for tails, right? It's going to be 250 for each. Now, it doesn't necessarily mean that it will happen that way, but the question is, how many times would you expect it to happen? And there is a difference between the real life outcomes and what we expect to happen a lot. Right, Karen rolls a dice and she got 252s. How many times do you think she rolled the dice? Well, in this particular case, we know that the chance of getting a 2 on a dice is 1 over 6, because again, like in one of the previous examples, there are 6 equally likely outcomes, the 2 being one of them. So if we took the amount of throws, let's just call it n, and we divided it by 6, we have got the outcome 250. This is a bit like a reverse problem from the previous example. So if I want to find what that original number was before it was divided by 6, I'm going to need to multiply my 250 by 6. And that is going to be 1,500. So how many times do you think she rolled the dice? 1,500. And we can always check, can't we? If we divide that by 6, do we get 250? Yes, we do. How many 6s do you think she got? Again, it's going to be exactly the same. It's equally likely to be a 2 as it is going to be a 6. So the answer to B is going to be 250. Right. Stuart chose a playing card from a full pack 100 times. How many times do you expect him to get? A red, a black, a heart, or a diamond? So we need to know something about cards before we can really answer this question. So if we have a pack of cards, and there are 52 of them, and just for your information, we have half of them red and half of them black. Okay, so half red, and that of course is 26. We have half black, another 26 out of the 52. Okay, so, and then from there, they're subdivided into different suits as well, with a quarter of each type of card, sorry, a quarter of the cards being of each suit. So a suit is hearts, diamonds, spades, and clubs. So a quarter are going to be hearts, and a quarter are going to be diamonds. And of course, that's 13 out of the pack of 52. Right, let's go through this then and answer the question. So we are going to choose from a playing card from a full pack 100 times. So how many times would you expect him to get a red card? Well, the probability is a half. A half of the cards are red. So we'd expect it to happen half of the time. So a red card will happen, we expect, 50 times out of the 100, half of that 100. The black card is exactly the same. It's also going to be a probability of a half. Okay, we're going to divide 100 by 2. It's going to be 50 as well. So the chances of getting a heart, well, a quarter of the cards are hearts. So we would expect a quarter of the times that we draw a card for it to be a heart, and a quarter of 100 is 25. Exactly the same for a diamond, because it's a quarter for a diamond as well. In other words, what we're doing is we're doing the amount times those probabilities, right? 100 times a half, 100 times a half, 100 times a quarter, 100 times a quarter. That's our way of doing this mathematically. Okay, that should help us to introduce expectation and some very basic probability.